x 2, and it's the 2 is right here, 2x, and you take 1 less power, so x squared would be 2x. So look at number 2, x2 cubed. So this 3 is right here, and you take 1 less power. So x cubed is 3x squared.
Let's see if it works every time. Okay, so I just now hit record. So for people that are watching this video, what's just happened is I've given 5 different groups in the class a problem to find the derivative of. So everybody found the derivative. We wrote them down. We're looking for patterns. Bryant at the front thinks he's figured this out. So let's see here. He says there's a 1 here. 2 times 1 is 2, and you take 1 less on the exponent. So that one worked. The 2 just became a 0, right? Just because the derivative of 2 is nothing. It's 0. We've got this little guy here. There's a 1 we can't see. 3 times 1 is 3. 1 less exponent would be 2. And I see that. So far we're working. Next one. 2 times 5 is 10. 1 less would be x to the first. So 10x to the first. There's a 1 here. 1 times 3 is 3. 1 less would be x to the 0. What's anything to 0? 1. So 3 times 1 is 3. So we're good on that one. 3 times 2 is 6. 1 less would make that squared. 6x squared. How about this one? Sure you do. Can't you rewrite this as x to the negative 1?
Oh, yeah.
Ah, and there's a 1 here. Negative 1 times 1 is negative 1. Subtract an exponent, we get negative 2. Isn't that the same thing? Ta-da! It's called the power rule. So let me pass out your notes for today so you've got all this and we can go a little faster. All right, let's pass this down. Does everybody have one? So what you've got on your paper, it says, if n is a rational number, meaning it can't be pi, can't be a square root of something bizarre, like radical 3, it's got to be normal rational number, then the function is differentiable, and kind of here's what happens, and this is what Bryant just explained. This right here is sort of fancy for derivative. So the derivative of the function, you just take the n, multiply to the front, subtract the exponent, just like Bryant said. That's going to make your life infinitely easier, right? Yay! All right. And the reason you have to learn, well, probably a couple reasons you have to learn the long way anyway. I do want you to understand why it works, but also questions do show up on the AP test from time to time that are asking that question, that want you to work it out the long way, because they're asking you to find a limit from the left and a limit from the right to see if it actually exists. So you want to make sure you do know how to do that long way, because that may show up in about a year for most of you when you're in AP. So here's some derivative rules, and a derivative is a limit. That's what it is. So what we've got here are rules that look just like the limit rules. The derivative of a constant is 0, which we kind of talked about that up here. Became 0. The derivative of just regular old x was 1. Now, if you've got a constant times a function, this is composition of functions, you can just take the constant times the derivative of f of x. And that looks just like those limit rules we learned. If you're adding a couple functions together or subtracting them, you can just add or subtract their limits or their derivatives. And then we just learned the power rule. So let's look at these little guys right here. Find the derivative. You guys do the first one. This is a lot like one at the top. One over x cubed is the same thing as x to the negative third power. There's a 1 here you can't see. Negative 3 times 1 is negative 3. Subtract 1 exponent, so we have x to the negative fourth. And you can't have that negative exponent, so we shove it to the bottom. Questions on the first one? All right. You guys work all those on that page. I'll work them out too. And if you need to sneak a peek and cheat a little, it's fine, or you can check your work. Try to do them by yourself. Bless you. So if you were finding a limit the long way on the first one, you'd probably just now be finishing up. It's kind of nice that we have this power rule. How are you guys doing on these? Are you getting most of them right?
Yeah. Can you walk through one of the ones with the portion?
Absolutely.
The two of them.
Sure. All right, so if we're looking at, for example, like this one right over here.
Yeah.
So I split it apart so you can see it a little bit better, that this also is the same thing as 2/5 x to the negative 2. So I said took negative 2 times 2/5, which is negative 4/5, subtracted 1 from the exponent, and so that shoved that x cubed to the bottom.
Wait, you squared 2/5? So, or how did you get the 4/5?
Negative 2 times 2/5. Yep. It'd be just like saying negative 2 over 1 times 2 over 5. Negative 4/5.
And you subtracted 1 exponent.
Correct. Mm-hmm. And then because it's a negative, that sticks it on the bottom.
That's positive.
Yes, correct. How'd you guys do on g of x? So radical x is the same thing as x to the 1/2. There's a 1 here you can't see. 1/2 times 1 is a half. Subtract 1 and you get negative a half right there. And that makes x to the positive 1/2 go to the bottom. And then that's radical x. And I realize that's not rationalized. And it's fine. I'm fine if you just leave it like that. Because a derivative, it's just a formula for finding something else they're asking for. So it's probably not going to stay like that anyway. You know what I'm saying? It's probably not going to be your final answer. Questions on any of that? Great. Look the paper over. Zoom out here. Find the slope of the graph. Slope, derivative, kind of the same. Of f of x at x equals 2. Same questions we've been doing, but now you have a power rule. So find the derivative. And then we want the slope. We want the slope. So put, 2 in place of x. So where x is 2, the slope of that line on that function is 80. That's super vertical. Questions? Everybody okay? I think you're probably not talking because you're writing on the next one. Is that right? Okay. Derivative of the next one. Most of you have already finished it. I'm going to talk it out loud just so I've done the power rule out loud one more time. 3 times 2 is 6. X to the second because we subtracted a number from the exponent. 2 times -4 is -8. Times x to the, that's going to be the first power. Plus, there's a 1 here. 1 times 3 is 3. X to the, that's going to be a 0. Anything to the 0 is 1. 3 times 1 is 3. And then this guy is a constant. He becomes 0. Questions? Terrific. All right, these little guys, put circles, stars, exclamation points, whatever, but you're going to have to memorize those. There are no quick little power rule tricks for trig functions. You just have to know them. I know you guys are not fans of memorizing, but it's not a big deal. There's 2. The derivative of sine is cosine. The derivative of cosine is negative sine. Here's why. We have the limit as h approaches 0, and let's say I'm going to find the derivative of cosine. Everywhere I see an x, I put in x plus h. Minus the original function, which was cosine of x, all over h. Now we need to get rid of that h on the bottom. There was a problem a lot like this, I think it was last week out of your textbook. You're going to have to do the sum and difference trig identity on this thing. It gave you a hint in your textbook to remind you of that identity. So when we're adding 2 angles together, you can just make it cosine of the first angle times cosine of the second angle minus sine of the first angle times sine of the second angle. And then don't forget to subtract your cosine x all over h. This is just like that assignment. And then I'm going to kind of rearrange this a little bit so that we can do some stuff with it. I'm going to put all my cosines together so that I have cosine of h times, cosine of x times cosine of h minus cosine of x. And I'll put all that over h. And then I'm going to put a minus, and I'm going to take care of the sine stuff all at the same time. Sine of x times sine of h, and that also has to be over h. Those 2 lines are mathematically equivalent. They mean the exact same thing. I've just rearranged it. You've got common denominators. If you shove them together, you get what you had up here. Anybody know why I separated those 2? Ah, special functions. I heard it. Because of our special functions. Sine of h over h, we know what that limit is as we approach 0. What do we do with these cosines? What if we take out a negative cosine x from both of them? If I take negative cosine x out of this first term, I'm going to have a negative cosine h. If I take a negative cosine x out of the second term, I get a positive 1. This right here is one of your special functions. What's the limit as we approach 0 for this first special function? 0. So I have negative cosine x times 0 minus, what's this special function? 1. Sine of x times, 1. So the 0 goes away, and I've got negative sine x, and that's the answer. And that's what we got right there on your notes. So that's where it comes from. We could work the other one, but I don't think we really have the time. If you want to, go for it. But this is what you're going to get. Have those memorized for sure, for sure, for sure. so that when you get to problems like the next one, that say differentiate that function, it's not really a big deal. Y prime, derivative of y is, this first guy becomes what? 2x minus, I've got a 2 here, but we remember from the derivative rules on the front, when you've got a constant next to a function, the constant just gets multiplied by the derivative of that function. So we're going to leave the 2 alone. And what's the derivative of cosine? Negative sine x. So that became a plus. Questions? There's not going to be any steps to show. You're just going to have to know it. Next one. You do it. How'd everybody do? Derivative of 1 over x is negative 1 over x squared. The derivative of sine is cosine, and that constant stays the same. All right. Next one. I'm sorry, what? Because the derivative of sine is just cosine, so it doesn't change the same. Because when you take negative 1 times 1, you have a negative 1. And then when you subtract an exponent, you're going to get negative 2, which sticks on the bottom. It was negative on the front. It's negative on the front. Good question. The next question is just what you've been doing. It's just with sines and cosines. So it's find when the graph, so we're looking for a location, probably an address, like an ordered pair, an x, y. Find when the graph of the function has a horizontal tangent line. Horizontal tangent line, what's that slope? 0. We have a function. We got to figure out where that tangent line is 0. So we're looking for slopes. What should I do? Find the derivative. So the derivative of x is 1. The derivative of sine is cosine. And I want to know where the slope on that function is 0. Here's the formula to find it. So let's set it equal to 0. Subtract 1 from both sides. Ashley says pi. She's saying that at pi, cosine is negative 1. Is that true? Yes. So where x equals pi. We probably need an x comma y. How do you get the y value that goes with that? You plug it in. So we have y equals pi plus sine of pi. So y equals pi plus, what is the sine of pi? 0. So our x and y's are both pi, actually. So at that point, on the graph, that's going to make a horizontal tangent line. Questions? All right, next one. Find k such that the line is tangent to the graph. So this line is tangent to this graph of the function. So they do give us a function. The problem is they didn't really complete it. They kind of left a mystery number in there for us to figure out. All right, well, we're talking about tangent lines. We know we're going to need to do derivatives, so let's just figure it out. So that I'm going to get 2x minus k. That's our derivative, yes? Okay, what do we, for this, what do we need this slope to be? 5, and that came from this guy over here. So we have 5 equals 2x minus k. I like to solve for k, so let's get k by itself. I'm going to add k to both sides, and if it doesn't freak you out, I'm going to subtract 5 at the same time. And we're kind of stuck, because I still have too many variables in here. I still don't really know what k is. I know how to get it if I have an x value. Let's go ahead and plug k into this original equation here to eliminate the k variable entirely. So f at x, I rewrite it as x squared minus, replace this, stick it right there in for k. 2x minus 5, and we're multiplying that by an x. We simplify it. So we have x squared minus 2x squared plus 5x. So we have f of x equals, because this x gets distributed. Yeah, I distributed the negative and the x at the same time. Sorry. Okay, we're looking for an address where this equation and this equation meet up. So what do? Set them equal to each other. Love it. So we have negative x squared plus 5x equals 5x minus 4. Subtract 5x from both sides. Divide both sides by a negative. And x is positive and negative 2. But did they ask for the address? No, they want to know k. What do I do with the x? And I'm going to draw a bunch of arrows because this is my notes and Mrs. Major's not coming home with me. So I need to know what I did. So I take the positive 2 and I plug it in. 2 times 2 minus 5 is negative 1. Negative 2. 2 times negative 2 is negative 4 minus 5 is negative 9. So there are 2 places where that line is the graph that matches up with the other one. Or there are 2 answers, I guess I should say, for k. Alrighty? Yes, ma'am. Because I was looking for a place where this function and this equation touched. So I need to know the address where that point was true for both of them. Alrighty? Alright, here's your assignment. And we also need to talk about the last problem on the notes from yesterday. So grab those notes. And it says to identify a function that has the given characteristics and then sketch the function. So we have to do 2 things. It tells us that the function itself, so here's f of x. The function itself at 0 is 0. So it's telling you a point on the graph is 0, 0. That's not bad. And then it says that the derivative at 0 is 0. Derivative is sometimes kind of a fancy word for slope. So if the tangent slope is 0, that means it kind of levels off here, doesn't it? Okay, so I'm just going to draw that little pencil straight line so I don't forget that for later. Then it says that the derivative for any of the x's that are is bigger than 0 for everybody except at this place. If the derivative, the slope, is greater than 0, that means on the original function, it had to have been constantly increasing. Wouldn't the slope of all of those places be positive? And that's what it's saying. The slope, the derivative, is always bigger than 0. Oh yeah, I should have kind of made that prettier. Sorry, my bad. Thank you. Is that what you're going to say, Ocean? Because it doesn't say that the y values are greater than 0. It says that the derivative is greater than 0. If you draw it like a parabola, those tangent slopes are all negative. And it says that the derivative, the slopes are all positive. So that's why your original function can't be a parabola. So yeah, I screwed this up. This should be kind of like this. So what kind of function is that? Cubic. Thank you, Nick. So we identified the function and we drew a little sketch of it. So that's how you're going to do that one, number 60 or whatever on your assignment. Okay, let me hit stop on this video and then let me talk about some of your stuff from yesterday.